Having cold hands sucks, and heated gloves never detect when your hands get too warm. We picked the Thermocouple out of the hat, and thought it would be great to solve just that. We tackled this problem by attaching our Thermocouple probe to a heated glove and controlling the temperature remotely.
But first, we're going to talk about how a thermocouple actually works. So a thermocouple is basically two wires of dissimilar metals. So we have a K-type thermocouple, and in a K-type, there's two wires, one of chromal and one of aluminum. And they're hooked up to the probe end here and then to a cold junction on the other end. So you measure the voltage difference across this cold junction and it gets you a temperature. For our thermocouple, it has a really wide range of -200 Celsius to 1350 Celsius, so thermocouples are really great for measuring really big temperature differences. But a thermocouple alone isn't a complete system for measuring the temperature, because when you're measuring between the probe end and the cold junction, you're only measuring the temperature difference between these two. So you need a whole other device called a thermocouple amplifier to measure in absolute temperature or even in Celsius. So to do that, what it does is it takes the voltage, it amplifies it quite a lot, and then it also adds an offset to it to convert from degrees Celsius to degrees Kelvin, and vice versa. So when you get your amplifier, it has a equation on it already that is the equation of the voltage to temperature for the thermocouple amplifier.
The MATLAB code takes a sample every 1/10 of a second for 5 minutes here, and this measurement system allows us to check the temperature of the glove in almost near time. And then down here you can see we have a control system which allows us to moderate the glove's temperature. So on output pin A3, we can control whether the glove is heating or cooling by just simply applying voltage or not to it. And this is called bang bang control. We chose this for two main reasons, and that is, first, achieving our set point exactly is not super crucial. As long as we get near our range, we are happy, so we have it within a degree or two at any given time. And secondly, implementing a more complex control system would have almost doubled the cost of the project as it stands. So now let's head over and take a look at our glove in a live demo.
Are you tired of heated gloves constantly getting too hot if you get moving? Or even getting too cold from sitting around because you turned them off when they became too hot? Now introducing the new heated Bang Bang gloves. They are super easy to use and super simple. All you have to do is follow these simple steps. Just put on the gloves, turn on the Bang Bang switch, and you're now ready to go about your day with the most comfortable hands around. If that's not good enough to convince you, here's Byron to demonstrate to you the technical of just how good it is to choose Bang Bang.
Now we're going to run the code for 5 minutes so that we can collect some data. So now, as you can see here, this is our data that came out. You'll notice that we only have our data in set points, and that's relating back to the resolution of our sensor and the resolution of our ADC board as we were collecting the data. But you can see that our set point is here at 30, and overall we generally stayed right around that 30 point where we wanted to be for the whole time. No matter what we were doing, whether we were running around, jumping up and down, if we were working, the glove would have just shut off more and conserved more power. Overall, these gloves do a great job of holding temperature that we set.
Call 1-800-BANG now to get your pair of Bang Bang gloves today. That's 1-800-BANG now.